All right. Hello, everyone. Welcome to this month's edition of Skype a Scientist Live. Today, we are going to be talking about space and specifically about plasma. There are multiple types of plasma in this world. We're going to be talking about the state of matter version of plasma. We're being joined today by Camilo Jaramillo-Correa, who will be telling us about what he does, and then you'll have the opportunity to ask all of your questions. When you have questions, please submit them to the Q&A box on the bottom of your Zoom screen. There's a question mark in a speech bubble. You can submit all your questions there. Please only submit them once, and we will get through as many as we possibly can over the next 45 minutes. One final piece of housekeeping. Our program matches classrooms like yours with scientists all around the world. If you would like to get matched just for your classroom, feel free to sign up. Our program is free. We have an excess of scientists this semester, so please tell your colleagues, teachers, that our program is free, available, and don't hold back. If you want to talk to somebody, we are here for you. You can sign up at skypeascientist.com. With that, I'm going to hand it over to Camilo. Thank you for joining.
All right, thank you for having me. Thank you to all the Skype scientists team, you, Sarah, and Ramona for being here. And obviously, thank you for everyone that joined us today. I hope you learned something new. I'm very excited to share something about things related to what I've learned, what I've been doing, what I do for my work. So as Sarah was saying, I'll be talking about plasmas and specifically about plasmas in space. If you've never heard what a plasma is or you think you don't know what a plasma is, don't worry, we're going to learn that today. And I promise you that even if you don't think you've seen a plasma, I 100% guarantee you've seen at least one plasma in your life before. So before I start talking about that, why am I talking about plasmas? So I'll just say that I'm Camilo Jaramillo-Correa, and I work as a scientist. So I'm a nuclear engineer, so not really an astronomer, not really a planetary scientist, but I work with planetary scientists and astronomers, and I work with plasmas from space. So I've learned a little bit of this and that while doing my job. I currently work at Princeton University, and I work in a lab. So all my job as a scientist is doing experiments in a lab. And I study mainly two things in the lab. So I study plasmas, and I study materials, and I study what happens when plasmas and materials interact. So we have a good example here. Let me set up my pointer so maybe people can see it better.
We can see your mouse.
Okay, you can see my pointer too?
Yep, looks good.
Oh, and my cat might be joining our call. He's a famous Skype scientist. Good time. So you have a good example of a plasma here, in case you've seen one of this. This is a plasma globe or plasma ball, sometimes it's called. It's like this glass ball that you can turn on, and you have like this centerpiece, and then you get this like lining looking thingies. And then as you can put your hand or your finger, you see the lining kind of going to your hand. So that's a good example of a plasma that you can see and play around with. But there's more plasma in nature that you have seen as well. So we'll learn about that. But to learn about plasmas, we can start talking about the states of matter. And we're gonna do like an imaginary experiment today. So let's imagine we're sitting in the lab, and we're going to do an experiment on this sample here, which is a piece of ice. So let's imagine we're sitting in the lab, and we have this super powerful microscope, and we're going to put the ice in the microscope. And then imagine you're looking through the microscope at the ice, and then you see like a blown up version of the ice. And then if our microscope were like super, super, super powerful, then we'll be able to see that the ice is made of these tiny, tiny particles. They're very, very tiny, and we call those particles atoms. And so everything here on Earth that we can see is made of these particles that's called atoms. And so in the first state, which is the ice we have here, we have it in the solid state. And in that state, the particles are in a specific way. So let's imagine our hands. You can do the experiment too at home or at school where you're watching this. Imagine your hands are like the particles from the ice. So in the solid state, the hands are like held together this way. So it's like a very strong connection between the particles. You can kind of like move them a little bit around, but it's very hard to move them and separate them. So the particles are like held together with strength. If we heat up the ice, if we just put temperature into it or energy into the ice, it starts melting and turns into the next state, which is the liquid. So we have our water in our case. And in that case, the particles are no longer held together like that. Maybe it'll be like a finger connection. So they can like move more freely around but they're still connected. So they have more freedom, but there's still some connection between the particles. So that's why liquids behave the way they do. They're kind of like flowy and like they can do the things that they do. If we put even more energy, so we keep heating the water, like imagine you put a stove, a pot of water on the stove and you heat it up and you start seeing the vapor. That's the water turning to the next state, which is the gas. And at that point, the particles are no longer bound together. So they're just like kind of like flying around wherever they want. They can go. So here's the animation again. They can just go wherever. So that's why like when you're boiling the water, you see the vapor going up and kind of like trying to fill all the room. And then we keep putting more energy into the gas. Then we go to the plasma state, which is the state that we're talking about today. So like I think my hand has this little bracelet here that I'm wearing, and I put energy into the gas, and then suddenly that bracelet also becomes free. So I have now particles flying around, but I also have some part from my hand flying around as well. And that's a plasma. So if you notice the animation here, you can see that some of the particles now have like no ring around them, and then some of the rings are flying around. So that part that comes out of the particle is called an electron. And so the electrons are now flying around. And so a good example of that is the lightning. So if you have seen a lightning in your life, congratulations, you've seen a plasma. So in a lightning, what you have is like the clouds, and then you have ground, and then there's a lot of energy stored between the two, and then you have like the air, which is like just the gas state. And then suddenly that energy goes through the air, and then it heats it up and makes the air turn from the gas to a plasma, and that's why you can see the plasma in that moment. Okay, so now we know what a plasma is, and now we can do our second imaginary experiment. So now we're going to go to space. So let's imagine we sit down in our spacecraft, and we just take off and go up to the solar system. So think for a minute about the things that you can see. So we're just like standing on our spaceship looking at the solar system. And so first of all, we see the sun, which is like the biggest thing in our solar system, is a big ball of, you guessed it, plasma. So if you've seen the sun, again, that's another good example of a plasma that you can see in your life. So we have the sun, which is that ball, a hot ball of plasma that's just like a lot of particles doing a lot of interesting stuff and like releasing energy. And then around the sun, we have usually the planets. So we have Earth, where we're standing right now. Hopefully everyone here watching this, I mean, I assume everyone here is on Earth. We have other planets as well, like the other 7 planets. And then we have the moon that we can see. And then other planets also have their own moons. So we have some moons in the solar system. We have asteroids, which are also flying around the solar system. We have comets, which are like kind of like asteroids, but they have like some ice around them that melts. And that's why you can see that tail when you're lucky enough to get one of the comets on our sky. And then we also have some spacecraft because there's just some missions that are just flying around the solar system doing their own thing. And kind of that's typically what we think of the solar system. So like if we imagine we just took our spacecraft and we just sit like in this empty spot here and we sit down for 100 years, we think nothing will happen. We think it's just like a very quiet, very boring place where nothing happens. But in reality, this is not true. There's a lot of things going on that we cannot really see with our eyes. And part of it has to do with the sun. So as I said, the sun is a ball of plasma. So all these particles are just like flying with high energy inside the sun. But then sometimes they're escaping. So there's like plasma being spewed out of the sun going in all directions. So anywhere you can stand in the solar system, you see if you're looking at the sun, you're probably getting plasma from the sun hitting you. And also, there's like this tiny dust particles, so it's like grains of sand that are flying through the solar system at very, very high speeds. So like kind of like when you go to the beach, maybe if you've ever been to the beach and it's like a windy day and the wind picks up some of the sand from the beach and it hits your skin and you feel like little needles or prickles. It will be something like that, but the sand or like these grains in space are flying so fast that it will just not be a prickle. It'll probably go through your hand and make like a hole. So it's like very, very high energetic particles. And so a more accurate picture would be something like this. We have a lot of energy just coming from the sun at all time, and then we have these particles flying around everywhere. So even if you're standing here, You might think that it's a quiet and boring place, but actually you're just getting bombarded with energy from the sun and plasma from the sun. And one thing there's a cool thing that happens when this plasma from the sun hits something. And to learn about that, I have like a short story here about these two kids that went to the beach one day. So before they went to the beach, their parents told them to put sunblock on because you have to protect your skin from the sun. So the girl on the left, she listened to her parents, she put sunblock on as she was told. But the kid on the right, he was like, "No, I'm strong. I don't need to put sunblock on. I'll be fine." And you can probably guess what happened after they played for a few hours under the sunlight. The kid got sunburned. And that's because there's a lot of energy coming from the sun, and that energy was hitting his skin. And he was not wearing a protective layer to like block out that energy from the sun. And so it caused that sunburn. And turns out something very similar happens in space. So as I said, the sun is always throwing plasma and energy in all directions. But here on Earth, we're very lucky because we have this nice umbrella that protects us from most of this energy. So some of this energy can still make it through the umbrella. So that's why we hear about the UV rays or UV light that we have to put sunblock on because that protects us from the UV. But most of the harmful plasma and energy coming from the sun is actually blocked by this umbrella. And so like we have actually two. So we have the atmosphere, which is like this layer of gas that surrounds Earth and that blocks most of the harmful light. But we also have the magnetosphere, which is like the magnetic lines from Earth, which kind of like bend around particles or plasma that comes. And so plasma never gets to us here on the surface. So most of that harmful energy will never hit us as long as we're under the umbrella. But if you imagine if you were to like go up and sit down here, you would get all that energy, no umbrella, you would get sunburned pretty quickly. But then we have another type of things in our solar system, which is the asteroids that we mentioned earlier. And asteroids do not have an umbrella. So they don't have atmosphere, they don't have magnetic lines, so they don't have anything to protect them. They're not wearing their sunblock. And so they're constantly getting that energy and that plasma from the sun. And so as you can think, you can imagine, it's like the asteroid just being sitting there sunbathing for hundreds of millions of years or billions of years. And so they're getting sunburned. They're getting like their tan. And this is something that scientists have seen and scientists study in the lab and also study using telescopes and models. And so here I have a great example. I think it's my favorite example of sunburned asteroids. So this asteroid here is called Gaspra, and this is a picture that was taken of that asteroid by a mission called Galileo. And so this picture has been photoshopped a little bit to make the colors more easily for us to see, but it shows what happens when the asteroid just sits down and sunbathes for a long period of time. So if you can see, the asteroid has like some blue or like gray parts that are kind of like usually surrounded by the craters. Um, and so those are like fresh skin from the asteroid. So it has like new skin that hasn't been sunburned because it's just like a newer skin. But then most of the rest of the asteroid looks like this kind of like maybe reddish, brownish, orangish color. That's the skin of the asteroid that's sunburned. So it's been just like sitting there for hundreds of millions of years or billions of years. And the just being exposed to that energy from the sun. And so the sun turned the asteroid red, just like our skin gets red under the sun. Asteroid also turned red, not for the same reason because our skin is made from one thing. Asteroids are made from just rocks and minerals, so they turn red for different reasons. But I think it's very cool that they also turn red. Um, yeah, and so that kind of does tells you what plasmas can do in space. And so we like studying these kind of things in the lab. So sometimes it's hard to go to space. It's expensive. You cannot just go everywhere you want in space. So one way we can do that is just by using labs here on Earth, where we can study plasmas and see what they do to different materials. So here I have a cartoon of what a lab where we study plasma looks like. So first, what you need is like an enclosure. So, oh, sorry, my cat's sitting on my keyboard. Okay, are we good? Yeah. Um, and so we have the enclosure, and that's because like plasmas don't really like existing in air. That's why you don't see plasma just like floating around. It's like very hard to create a plasma normally. And so one way we can do it is just have this like box and we just take out all the air and just create like a vacuum, just like in space there's vacuum. We create a vacuum here on that enclosure, and that way we can make a plasma more easily. And then we want to study something, so we put like whatever thing we want to study. So we want to study a rock or a material, we put it in there, and then we have a plasma machine that just like throws or shoots the plasma at that material that we want to study. And then we have these special cameras that we use to look at that material, and then it tells us what's happening to that material when the plasma is just interacting with it. So a good example of that is a picture I have of one of the labs where plasmas are studied like this. So they look something like this.
Oh.
And there's like a lot of things going on here, but I'll show you the main parts here. So let me turn on my laser pointer again. So here you can kind of see a metal part in the center. That's kind of like the enclosure. That's like the sealed part where we can do all these experiments. So as I said, that's closed so that air cannot go in. We just pump out all the air with like special vacuums. And then all of these things that you can see are like pointing in the same direction. All of those are like different cameras and plasma machines that we can use to then like shoot the plasmas. So we can put something inside of here, shoot the plasma, and then we'll use all of these cameras to just look at what's happening there. So that's like what a plasma lab looks like in real life. Cool. All right. That's all I had to share.
That's awesome. Thank you so much. That was very cool. Okay, we got questions. As you all have questions, please submit them to the Q&A and we will get going. Okay, so you have in your contraption, for lack of a better word, that studies how plasmas interact with objects. The first question people had is like, why do you want to know how plasmas interact with objects? What's like the downstream like uses for that knowledge?
There's many applications. So I just shared one application, which is what plasmas from space do. But we also study. We're trying to make like one example. We're trying to create energy from a process that happens in the sun. So as I said, the sun is plasma. So we're trying to create like a mini sun here on Earth. So that'll be like a hot plasma, and we have to put it inside a machine to create energy to like feed our electricity grid. And so that sun is very hot, and we have to put it inside something. We have to make sure that whatever is that enclosure can like keep that sun inside, because otherwise you'll just like break the machine and then it will just turn off. So we have to understand what the plasma is doing to that machine so that we can keep the process running. Or we also like, I think the most common application for plasma is we used to make it every like chip, every electronic device, it's made with plasmas. So plasmas are very nice because we can control them very easily in the lab. So you can make tiny things. And so that's all done with plasmas. And so we like to understand how plasmas can be used to create all these micro chips that we can put in our phones, computers, TVs, and everything.
Cool. All right, great. Our next question is from McGinnis Woods first grade class. What is your cat's name?
My cat name is DOG. So it's like spelling dog, DOG. Uh, yeah, that's his
Nice.
name.
Sounds good. A couple people asked about the universe expanding like into infinity. Like what can you like talk a little bit about what that's all about?
Yeah. So this is when we look at like even so we were talking about the solar system today, and the solar system is just like a little tiny like neighborhood of the universe, which is like a humongous, I don't know, city or country when you compare to like just a block of the solar system. Um, but imagine you have like one solar system here, and then like your house, and then there's a street, and there's another house at the end of the street. And imagine that street is made like of a rubber band. And so the rubber band is just like getting stretched out. So everything is just moving apart from each other in space. And that's because at the start of the universe, everything was in one point and everything kind of exploded. And everything is just like moving away from each other.
Cool. We've got Andre from Garden Spot School. What is the education required for your job?
So to study plasmas specifically, I worked with many people with very different backgrounds. So there's people that are specialized in plasma specifically. As I said, I study materials too. So there's people that work on materials, so material scientists. I work with geologists because we study rocks. Um, I work with engineers because we use machines that we have to build. Um, so there's like a lot of backgrounds that you can end up doing things. Like my background's in physics, but I have colleagues from work that have backgrounds in engineering, mechanical, you name it. Yeah, there's so many things you can do.
Cool. And do you work with people who have like bachelor's degrees, master's degrees, and PhDs, or
Yes.
just one
Yeah.
of
So
those?
science is very cool because it's like it allows people from all levels. So at the lab where I work at right now, we have undergrads, we have high school students that had do like summer short internships. So we have everything from like high school all the way to undergrad, masters, PhDs, and then after PhD people all the way to like professors who have been working in the field for decades. So
Very
you
cool.
have everything.
That's what makes science so fun. That's so
Yeah.
true. Awesome. A couple people have asked, how expensive is the machine that makes the plasma and that whole like contraption that you showed us? Like, how much does it cost to make one of those?
Yeah, it can get it gets as nice as you want it if you have the money for it, but the basics, like if you want a plasma machine, like a nice lab grade plasma machine, it could be like maybe 15,000. Hello, DOG. The machine itself, you can buy it for cheaper. It's probably like 2,000, 5,000. I'm based on prices that I knew like 2 or 3 years ago. But you can make plasmas for cheaper. There's like simpler ways to make them for like $500 or so.
Cool. Um, that's actually less expensive than I was afraid it was going to be. The like
Like
I'm
like
like I'm
some of
sure.
the cameras can be like 200,000. Like the special instruments that we use to analyze,
Yeah.
like be like 2 or 300,000. So like the machine I showed in the picture is probably maybe around like $450,000.
Wow. That's wild. Yeah. Science is expensive. That's why we need federal funding for it. Um, all right, from Seoul Finestone Elementary School, if we didn't have an atmosphere and magnetosphere, what would happen to us?
Okay, that's a very cool question. I love that question. So we have a good example with that, and it's Mars. Mars kind of used to be similar to Earth. Mars had its atmosphere, it had like water, but then Mars, uh, being a smaller planet, sorry, being a smaller planet, it cooled down faster, so its magnetism slowed down faster than Earth's, so it lost its magnetic field. So you get like the plasma from the sun constantly hitting Mars, and so it eventually like wiped out the atmosphere. So Mars used to have an atmosphere, but now, because it doesn't, the plasma from the sun just like wiped it out. So it gets exposed. Now it kind of have like all the nice things that maybe we have here on Earth, because then all that radiation is hitting the surface and it doesn't make like a nice place to live.
Add that to our cons list for moving to Mars.
Yeah.
Not a great idea. Yeah. Doesn't even have an atmosphere. Or does it have no atmosphere or just
I
very
think
little,
it's like very
like
thin.
a really
So
thin
yeah.
atmosphere? Okay. We've got a question from grade 5. When did you like start to think you might want to do this job when you were younger?
I think when I was a kid, I loved, so my favorite thing to do when I was a kid was playing with Legos. I loved building things, and I think that's when I started, even if I didn't know what I wanted to do, but I loved building things even when I was a kid. And then when I was in high school, that's when I started learning about physics, and I love the fact that physics could tell me how things work in the real world, and I could look at the real world and see like, well, wait, physics is telling me it's gonna work this way, and I look at real life and it works this way. So that's when I kind of fell in love with that, and then I wanted to use physics to do something. So when I went to college, I chose a program and a path that would like let me use physics to do science, because it lets me like discover and study how find things in the lab that let me explain how things in the universe or in our Earth work.
Very cool. That makes sense. Okay. We've got a bunch of questions about multiverses. Do you think that there are multiverses?
That's a hard question. So I'm not an expert by any means in this field. So I'm not sure. I don't have the knowledge to say whether there are or not. I think
Either.
yeah, there's people that study like more levels of physics that maybe have a better answer. I wouldn't know.
On a similar, maybe you don't know answer. Do you think there's life in other galaxies? That was another question we had.
That's a good question. I can answer not as a scientist. So as a scientist, I cannot say because I don't have evidence to say that. But as a person, I think maybe because the universe is just so big that I think like it's kind of likely. Like if we think about the number of planets that there are in the universe, we cannot even like imagine the number in our head. So I think like it's not that unlikely. But
Yeah,
everything is just so far. Like if you think the closest star to our solar system is 4 light years away, and then imagine everything else that's just farther away. It's just like even if there's something else, maybe there's hasn't had enough time to just get any information. So I don't know.
hard to
It's just
fathom
a
it.
personal opinion, non-scientific.
Yeah. Sounds good. I'm voting yes on that too, as a person who studied microbes for a while. Yeah, probably. I don't know.
Yeah.
Our next question is the Milky Way made of plasma? Is there plasma in the Milky Way? We're in the Milky Way, I guess.
Yeah. Yeah, I mean, most of the Milky Way, there's a lot of stars. So, like in our solar system, most of the mass from the solar system is a star, which is a plasma. Same with the Milky Way. Like a lot of the material from the Milky Way is just other stars. So, there's a lot of plasma. So, and yeah, I think in general, the universe is like 99% plasma and something like that. I don't remember
Wow.
the number exactly, but like, here on Earth, we live in like a special place because we don't see plasma very often, but for the universe, that's like a very rare thing. It's like most of it is plasmas.
Cool. Sebastian wants to know, are all plasmas dangerous?
No, no, there's many cool applications. So there's medical plasmas. So we can make these plasmas that are like little jets and you can like treat wounds. Like if you have a wound on your skin, you can use plasmas to like kill the bacteria and like make it heal better. So there's plasma that you can touch with your skin.
Whoa,
Uh, and then there's plasma that are dangerous as well. So there's a wide range.
cool. Can any element be made into a plasma? Can plasma be made of anything?
In theory, yeah, if you have enough energy, you should be able to, but some elements will need a lot of energy that we can probably not like create realistically in a lab right now. And some elements are easier to make plasmas out of. So as I said, it was like you have the particle and you have like the electron. It also depends like the energy at which the electron is kept together with the particle. If the electron is kind of like very loose, it's very easy to take it out and make a plasma. But if it's like very strong, it's very hard to like make the
Get it
plasma.
loose.
It depends a lot.
Okay, cool. Mrs. Kugel's fifth grade class wants to know, is there any sound that plasma makes?
No, they don't make sound, but
No
they
sound.
shine light so that they have very specific colors. And so if you make plasmas of different gases, you'll get different colors, which is very cool. There's like a lab demo that maybe you can find like discharge tubes. So it's like the glass tube that's filled with a specific element, and each element will shine like a different color.
Cool. I know you can make like you can light different elements on fire and make different colors of flame
Yeah.
too, which is fun. Is that related at all or
Sometimes I think some of the colors might be chemical. I'm not sure.
huh? Like does I don't necessarily expect you to know this off the top of your head, but I know like copper makes a green light.
Maybe. Yeah.
Maybe does it all if we plasmafy copper, does it do the same? Is the color that you make when you set it on fire the same color as the plasma? Or are these two
I
things
actually wouldn't know. I haven't thought about that because I don't think it's easy to make a plasma out of
whip them
copper.
up in the
So
lab?
yeah, I'm familiar with it. Yeah.
Huh, cool. Um, is there lightning in space?
No, because you need so lightning is like air that's being turned into a plasma, and in space you don't have air, so you don't have a way to make lightning.
Cool. Um, Alden wants to know, what is the special camera called that captures the plasma on a photograph or picture?
Okay, for just to take a picture, you can use like a regular camera, like your phone can probably take a picture of your a plasma very easily. But there, when I said camera, they're actually like different types of instruments that look at different things. So they're not always giving us pictures. Sometimes we get numbers, and we have to like analyze the numbers. So camera was like a loose term that I was using to explain that we have something that looks at the plasma and then gives us some information. Sometimes it's in pictures, Sometimes it's in numbers.
Cool. Finley wants to know, how hot is plasma?
Plasmas can be as cool as like room temperature. So that's why I was saying like you can touch
Oh,
um,
right.
a plasma with your finger, but they can also be as hot as like millions of degrees or hundreds of millions of degrees.
That's wild.
So that's why
Um,
like, the sun is a good example. It's like a very, very hot thing made of plasma, but we can also touch a plasma here on Earth.
right. Cool. Um, is the Earth's, or is there any plasma in the Earth's core?
Um, I'm not sure, but I would say probably not.
Cool.
I think the core itself is kind of like a solid-ish iron ball, and then there's like a liquid magma around it.
Hmm.
So there's not plasma there.
Oh, this is a fun question from grade 5 ABM. What is the connection between plasmas and aurora borealis?
Oh, nice question. I love that one. So we have the Earth and we have the magnetic lines, and then we have like the sun here. Let me get the guess again out. So we have like plasma coming from the sun, which are like these particles, and then as they get to the magnetic fields, they kind of like bend around. But sometimes they have enough energy to like bend around and go into the part where the magnetic lines go into Earth. And so they hit the atmosphere in those points, like in the north and south of the Earth. And so when they hit the atmosphere, they transfer that energy into the particles from the atmosphere, and then they excite the atoms from the atmosphere and then make it into like a plasma as well, and that's why we can see it. So plasma like they produce light as well, so that's where you can see that.
Cool. It's on my bucket list to see those. I haven't seen them yet.
Same, same,
They
same.
keep like showing up here, and then it's always cloudy on the nights that they show up in like our region this year. What a
Yeah.
bummer. Anyway, uh, Bluey Williams's class wants to know, what is the favorite part of your job?
I think my favorite part of my job is being in the lab. I think I chose this profession because I love doing experiments. And so I get to sit down in the lab and just like run experiments and like think, okay, what should I do next? Or like, this is not working. How do I fix it? So I love sitting in the lab, but as a scientist, you don't always get to sit in the lab. Sometimes you like get the results from your experiment and you have to go sit down in your office and analyze them. So sometimes I sit on the lab on my office, and then my favorite days I sit on the lab just like pressing buttons, turning knobs, and seeing things happen.
The pressing buttons, turning knobs days. Peak
Yeah.
science. That's good. Matthew from Garden Spot wants to know, is fire a plasma or is it different? How is that related?
Good question. I think yeah, it kind of is a plasma, but there's also some chemical reaction going on, so it's like a combination.
Cool. Benjamin wants to know, is there a way to know how much plasma is in a star?
Um, yes, I think I don't know if we ever measured that, but I would say that most of it, if not all of the star, is made of just a plasma. Because um, I think it's a relationship with how big the thing is, and so that's why like the brown stars, or I forgot what they're called, they like kind of cool down and don't look so much like a star.
Mhm.
But then the bigger ones, just like they're so big that there's so much energy, and so it's mostly just plasma.
Cool.
Yeah, that's a hard question.
Yeah. Yeah. Corey wants to know, I've heard about people donating plasma. Is this the same as plasma from the sun? What plasma is in our body?
I love that question because I often, when I say I'm a plasma scientist or I study plasmas, people usually tend to think that, or like many people are familiar with the term plasma as like the blood. So we have plasma in our blood, but it's a different plasma. It's unfortunate they chose the same word, but they're different things. We don't have plasmas in our bodies. We have the plasma blood, which is a different thing.
Yeah, plasma is just your blood without the red blood cells in it. So actually the red and the white blood cells. They spin. So when you take a sample of blood, you can like spin it around really fast to remove the heavy stuff in it. And so the heavy stuff is the cells. So that's going to take your red blood cells and your white blood cells out of it. And then it's kind of like a pale yellow liquid. That's the plasma. That's like what your blood cells float in. That's body plasma. Doesn't make any light. Uh,
Very different thing.
very different thing. Yeah. Um, Oh, is there lightning in the hurricane on Jupiter?
Good question. I do not know for sure, but I would guess very likely because you need for a plasma to be there, you need like a gas, and Jupiter is just a gas giant, so there's a lot of gas to make plasmas out. And as long as you have enough energy, you can probably get the discharge to make that gas into a lightning.
Cool.
I might remember some like imaging from one of the missions might have taken lightning evidence. Maybe not on Jupiter, but they're lightning somewhere else in the solar system. So it's just not a thing from Earth. They happen somewhere else too.
Cool. Um, we got fifth grade from Philadelphia Performing Arts Charter School, Mrs. Montecalvo's class. What planet and star is most interesting to you?
Um, Planet, I don't have a favorite planet. I think scientifically they're very interesting, but they're not very welcoming to us. I do like a moon a lot. It's Titan, which is a moon from Saturn. And I like it because it's like the second nicest place for us to ever exist if we ever were to go somewhere. So Titan has an atmosphere and it's close enough to Saturn to be protected by Saturn's magnetic field. And so you could, as long as you have a thick enough jacket and like some oxygen tank, you could in theory walk on Titan and be fine. Whereas, like we said in Mars, radiation from space would just not be good for you right away. So I like Titan, which is not a planet, but it's a moon in our solar system.
Cool. Oh gosh, I had a question and then I lost it. Is this session being recorded? Yes, and it will be on youtube.com/Skype a Scientist. What happens when you go into a black hole?
What happens into when you go to a black hole? So a black hole is just like kind of like imagine the sun, maybe like a star, but it's so strong, like the gravity is so strong that it doesn't even let the like light or the plasma escape from it. So it's not really a hole. It's just like a star that is so compact and so strong that not even light escapes. And so if you were to go there, we just kind of like fall down into it. But you get this like spaghettification because like gravity is so strong that it will start pulling you apart. So you'll become like spaghetti and as you're falling down into it. And then we don't really know what happens once you get past the radius. Yeah, it's
Can
just
be good.
theoretical.
Yeah. Um, we've got Stella from Mrs. Edwards' class. What exactly is the Earth's magnetosphere and does it have plasma within it?
So the Earth is a cool thing. So Earth in the center has like a liquid core and it's made of iron, so it's like a metal. And when this metal iron core is like turning around as the Earth spins as well. And so that movement creates these magnetic fields that like come out of it and then surround the Earth. So there's like lines that go around the Earth like that. And so there's like invisible magnetic lines surrounding the Earth. So they're not really plasma, they're magnetic lines, which is like electromagnetic like fields. Um,
Where
but
do they
they
come
cause a
from?
plasma when they interact. They come from that rotation. So when the core rotates, it
Uh-huh.
creates some currents that then create these yeah, magnetic lines.
Cool. May wants to know, what is your lab time to computer time ratio at your job?
I think it varies. It depends because sometimes you have like a lot of experiments you're doing, sometimes you have a lot of results. So I would say like maybe 60% experiments, 40% like office work.
That's pretty good.
Yeah.
Um, all right. Emma would like to know, what was your favorite book when you were a kid and what is your favorite book now?
My favorite book when I was a kid, that's a good one. I did like reading a lot when I was a kid. Um, Maybe I think so when I was a kid, all the Lord of the Rings movies were coming out. So I got into that hype and I loved the books and I read everything by Tolkien, I think that was available at the time. So if I had to pick something, I used to love those books a lot. So the Lord of the Rings, like the three books. And what was the second question like right now?
Mhm.
Um, my favorite book right now is called The Martian Chronicles by Ray Bradbury, and it
Mhm.
kind of tells it's like a collection of short stories, um, telling about humans colonizing Mars. So it's like explaining the moment it starts, like the first human going to Mars, all the way to the end of like humans move to Mars and then destroy Earth because humans are just sometimes not the best. Yeah.
Yeah. Sometimes not the best. This year has been a real demo of that. Yeah. Well, thanks for the answer. We got one more question from Corey. As the sun, and a couple people asked very similar questions. This is from Corey and everybody else who asked this question. As the sun sends out plasma, is more created to replace it? Is this like a renewable source? Like, where's it all coming from?
Cool. I love that question too. That's a very good question. So no, the sun is just slowly losing mass. So it has a limited amount of plasma inside, and it's always like throwing out that plasma. So it's very slowly losing it. But the thing is that the sun is so big, it has so much fuel that it will just keep running for a long time before that happens. And I think actually, uh, at some point, as it starts losing mass, it obviously start getting smaller in gravity force, and so at that point, it'll just turn off. So it'll stop being like a star because um, the balance of the forces inside will just like not work anymore. So it's slowly dying because it's slowly throwing its own plasma away, but it'll take too long for that to happen.
Cool. So we don't have to be too worried. It's not on my list of anxieties for the year.
No.
That's good. Cool. Okay. Well, we have been asking you questions for about 42 minutes. So that's all of the submitted questions we have time for. But we always ask everybody the same two questions at the end of every one of these sessions. The first question is, if you had everyone's attention in the whole world and you could tell them one thing about your area of expertise, what would it be?
Okay, hard question. About my
Next
area
one's even
of
harder. Yeah.
expertise, I think sometimes like related to like studying things in space, I often my friends would ask me like, why do we care? Like, yeah, there's a rock in space and like it's getting sunburned, whatever. Like, why do I care? I think there's like two components to this. One is like there's a lot of science behind studying this thing. So just because we're studying a rock in space doesn't mean there's a lot of things going on here that eventually produces things that we don't know that might be useful for our daily lives.
Mhm.
But also because like I think a very nice thing about humans is that we something that makes us special is that we like to answer questions about the universe. Like that's the way we've been doing for like our thousands of years that we've been around. So just being driven by the love for knowledge makes us like special. So I think that makes it very cool.
That's a really good answer. Really good answer. Okay, the next question may be even harder. You still have everyone's attention in the world, and you can tell them one thing about anything. This can be serious and significant, or it can be just frivolous and silly. You can tell them one thing. What do you tell them?
Mm, I think I would tell everyone to just um, remember to be kind to each other, um, because we like everyone has their own life, their own stories, their own like problems and happiness and everything. So um, sometimes it's just like very easy to make someone's life better, but just like a single gesture, like saying something nice or like giving them a candy. So just try to be nice to everyone, be kind because you never know why like something small that you can do might be the day for someone else.
Really good answer. This session was a good thing today. I had fun learning from you today. So thank you for sharing all about plasma and space and your studies. Is there anything else you'd like us to know? Anything else you'd like us to plug before we say goodbye?
No, I think that's it. I enjoyed this a lot. I think it's pretty cool. I hope everyone watching this learned something new. And yeah, I mean, I thank Skype as Scientist because I've been doing this for years now, and I think it's a great program. So I'm very happy to be on this space this time.
Thank you so much. Everybody at home, thank you for coming, or at school probably. Thank you for coming. We'll be doing another one of these in about a month. That will be all about how shrimp swim. That's sort of the study of what we call biomechanics, like how animals move and how animals do stuff with the way that they move, biomechanics. And shrimp are cute. So we're going to learn about how shrimp swim. So that'll be next month. And then we'll be taking off for the summer and see you again in the fall. As always with these sessions, we had more questions than we could possibly answer. So if your class is really curious, you can have a scientist just for your class. You can sign up at skypeascientist.com, click sign up, fill out the admittedly kind of long Google form, and then we match up everybody once a week, typically on Thursdays, typically get a match on Fridays, and it's free. So tell your friends. We want to match more people. So that's all I got for you. Ramona, thank you for your help today. Camilo, thank you for joining us and teaching us so much. We'll see y'all next time.
All right. Bye, everyone.
Bye.